Hello students, how are you all? I hope you are doing amazing. So I'm Krina Dayani, welcomes all of you at AriserTalent. So we have started the chapter of our physics, that is the magnetic effect of the electric current. But before continuing with this chapter, let us have a today's thought. Opportunities do not happen, you create them. So this quote basically specifies that opportunities will not come in your way that I'm opportunity, just accept me. So what you have to do, you have to create your opportunities, and you will create opportunities when you have a great idea of thoughts, inspirations, and you have a very good knowledge about it. So suppose you are going for any competitive exam, so the opportunity will not come in your way as you want. You have to create the opportunities and you have to get a very good marks for further appearing in the further sessions, or you can say that the further competitive exams. So what you have to do, you have to need a complete or a correct guidance of all the subjects you are studying for getting the good marks and for appearing in the good colleges you have. Suppose if you are getting the good marks in IIT, you will get a good college for engineering. So if you are getting a good college for the engineering, then you will get a good job. So this is a interconnected chain, we can see that. So for that, you have to clear all the concepts of the 9th to 12th that you want. So here AriserTalent provides you a complete course package for 8th to 12th class that we are having. So it is providing a complete video lectures, and you also have a study material with a very good content and a very good quality videos. So subscribe our channel, that is AriserTalent. Here you will get whatever you want. So this is what about our today's thought. So for creating your opportunities, you will need a very good guidance. So this guidance will be provided by our master teachers. So just follow our channel, subscribe our channel, and go through each video lecture very clearly. So this is the thought for today. Now let's start with the chapter we are discussing, and we are discussing the chapter that is about the magnetic effect of the electric current. Now, in magnetic effect of the electric current, before starting the new topic, let's have a quick revision that what we have discussed in the previous lecture. So in the magnetic effect of the electric current, firstly, we have seen an introductory part in which we have seen few examples and about the concept that is magnet and magnetism. Then we have gone through a lecture in which we have a discussion about the magnetic effect of the electric current and magnetic effect lines that we have seen. Magnetic field lines are also known as the magnetic lines of the force, and we have seen a several type of the lines regarding bar magnet, horseshoe magnet, solenoid, etc. Then in our previous lecture, we had a very good discussion about the magnetic fields due to a straight conductor, due to a current carrying coil and a solenoid. And we also discussed about the thumb rule that will give you the direction of the magnetic field and current. Now, in today's lecture, we are going to deal with a very important topic, and it is a very interesting topic, that is about the electromagnets. So, today we are going to start about our new topic, that is electromagnet. Now, before starting electromagnet, firstly let us see the practical examples we have in terms of the electromagnet. So, what you have seen that you have seen a crane. In that crane, basically a strong electromagnet is attached. So whatever the iron object we have to carry from one place to another, we just use that crane. So that crane basically works on the electromagnetic principle, and it is based upon the magnetic effect of the electric current. So to carry the heavy loads in factories and industries and so many places, it becomes not simpler to carry the iron object from one place to another. So for carrying this, you must needed a strong electromagnet that will attach or that will stick to that iron object and carry it from one place to another. So for that purpose, we will use the cranes we have. So similarly, This electromagnet does not have its application only in the cranes. It has found its application in a wide variety of familiar things you know. So, just start the electromagnet here. But first question is here that what is electromagnet? So, electromagnet is basically a soft iron core which is placed inside a solenoid and having a large number of the wirings of the insulated copper wires. So, what is electromagnet? It is a piece of magnet in which soft iron core is placed inside a solenoid. What is solenoid? That we have discussed in our previous lecture. It is a cylindrical metal rod having a copper wirings wrapped over it. So, inside a iron core placed inside a solenoid, and this is having a wrapping of insulated copper wire. So this is what actually the electromagnet is. It is a piece of a magnet in which soft iron core is basically placed inside a solenoid and having a large number of turns of the copper wire, we can say. So let us see the diagram here so you can be more clear that what actually the electromagnet is. So we are having a solenoid. In that solenoid, you have to place a soft iron core, and here we are connecting it with the battery. Here we have placed a key, and here we are wrapping the number of turns of the copper wire. So this will indicate the number of turns of the copper wire. This will be positive, this will be negative, this is our battery, and this is our key. And this is what we have as electromagnet, and these lines are representing the insulation, or we can say that this will be represent your number of turns of copper wire. So this is what the electromagnet looks like. Now, on what principle this electromagnet is working? This electromagnet is actually working on the principle of magnetic effect of electric current. What is the principle for the magnetic effect of electric current? As soon as you can pass the current in the circuit, the magnet will induce a magnetic field around it. Or as soon as the magnetic field is created in the circuit, the current will going to be passed in the circuit. So current and the induction of the magnetic field in a particular system is same activities. So what will be the principle involved in electromagnet? So the principle here is, this is the construction part we have. And this is our principle. So electromagnet is actually working on the principle of magnetic effect of electric current. So we can say that it works on the principle of magnetic effect of electric current. Now, this is the principle of electromagnet we have, and in the construction what we have seen, we have taken a soft iron core placed in a solenoid having large number of turns of copper wires. So This is all about the construction we have. Now, how it actually works, as soon as the current is passed in this system, suppose I am passing the current, so current will be flown from the positive terminal of a battery. If current is passed in this system, so you can see that this is our south and this pole will be our north pole. Now, as long as current will be passed in the system, this will going to behave as a strong electromagnet. So, as soon as this there will be the stoppage of the current, the magnetism of this system will be lost. So, that's why we are using the soft iron core here. Why we are not using the steel or any other compound? Because the soft iron core has a tendency that on providing the very low magnetic field, it can be magnetized very easily. But for using the steel or other iron objects, you will need a very high magnetic field to magnetize that objects. So what will happen here? As soon as the current is passed through this system, this will going to behave as a strong electromagnet. But when you stop the flow of the current in the circuit, the entire system will lose its magnetism. So this is how the electromagnets are actually working. And just now we have seen an example of crane here. What crane will do? Crane will having a big electromagnets attached to it. So whenever you have to lift any iron objects from the surface, you just brought the crane near that iron object and it will lift that iron object from one place to another. So it means it has a tendency to take or to carry a very big loads. It means this will conduct the current only, or this will create the magnetism only as long as the current is passed through it. So it means if I am talking about the working of this electromagnet, so this will be our working. So as long as current is passed, it will produce magnetism. But in the second case, when you stop the flow of the current, when there is no current, magnetism will lost. So this is how the working of the electromagnets basically take place. So what you have to remember, this question is your actually the theory type question. So you have to ask in the exam that what are electromagnets, what is the basic principle on which electromagnets work, and what are the applications of electromagnet in your day-to-day life. So you have to learn this question, or you have to remember this question as a theory wise question. So firstly, you have to write the definition of that particular part. Then after, you have to show the construction step. Definition, construction, then after you have to write the principle, and after principle, we should talk about the working of electromagnets. So this will be your 4 parts in the sequence we have. So this is how the electromagnets work. So firstly, copy this part from here so we can proceed to the applications of the electromagnet in our day-to-day life. So now, let's see the application of the electromagnets we have in our day-to-day life. So our next topic is about applications of electromagnet. First application we have seen about the electromagnets, that it is used to lift a very heavy iron objects with the help of the crane. Now, it is also used for loading or for carrying the metal or iron scraps that is found in the factories or industries. So, first application is regarding the crane we have. Second example of electromagnet is that you can also found the electromagnets in your bells. Electric bells also having an electromagnet inside it. So the bells you are used in office and in your homes mainly consist of electromagnet we have. Third application of the electromagnet is that in the hospitals, doctors usually use electromagnet to carry if any iron splinter will fall in your eyes. So during a surgery, if any iron splinter or iron object will fall in your eye, it can be easily attracted with the hues of that electromagnet. So you can found that it has found its application on the medical field also. It is the third application of the electromagnet we have. Fourthly, electromagnets are also used in telegraph, and it is also used in the telephonic instruments. So the instruments that the telephone we are used in the earlier times, having a one wire connection in it and having a one system like this, but nowadays we are using the cell phones or the mobile phones, so they do not have a such electromagnet in between them. So the telephones used in earlier time also have a very big electromagnets installed in them. So this is about the applications of the electromagnets. So this is again a theoretical question which can be asked in your CBSE exams. So the first application of the electromagnet will have, it is used in cranes. Firstly, it is used in cranes to carry heavy iron objects or metallic scraps. Secondly, electromagnet found its application in electric bells. So the first application is in cranes and second application is in electric bells. It is used in electrical bells at homes and offices. Third application is, it is used in medical field. Third application is used in medical field, or it is used in hospitals to remove the any metallic splinter falls into our eye eventually or during the surgery. So it means any metallic splinter or any metallic scrap falling in your eyes, this can be easily detached from your eyes by using a electromagnet we have. Next application is, it is used in telegraphs, telephones, etc. So it has also found its application in telegraphs, telephones, etc. So this is how the electromagnet has found its application in almost every field in our life. So these are the applications of the electromagnet. Now we have to discuss on what factors the electromagnet or the strength of the electromagnet basically depends upon. If the electromagnet is working, there must be several factors on which it must be dependent upon. So basically, it is dependent upon the number of turns of the copper wire. We have seen in the diagram of the electromagnet, just before that, you have seen that insulated copper wire is wrapped on a solenoid. So the number of turns increases, the strength of the electromagnet also increases. Secondly, if you are increasing the amount of current, if I am going to increase the strength of the current in the electromagnet, then again the magnetism will going to be increased. Thirdly, in case of electromagnet, you have seen that there will be the air gap between the two poles. If you are increasing the air gap, the electromagnetism will going to be decreased. So you have to keep the air gap as low as much possible, because if the air gap is going to be reduced, the electromagnetism will increase. So this is how on certain factors the electromagnetism will going to depend upon. So first copy these applications from here. So let's discuss about the factors on which the strength of the electromagnet depends upon. So next will be the factors on which electromagnet depends upon. So there will be several factors on which the electromagnet depends upon, but basically it is dependent upon the three factors we have. The first factor is about the number of turns. The second factor will be strength of current. And third factor will be the air gap. So these are the three factors basically on which the electromagnetism depends upon. These are the three factors on which the electromagnetism is going to be dependent upon. So if I am increasing the number of turns of the coil, the strength of the electromagnet will going to be increased. So the first factor we have will be, if number of turns increase, if number of turns are increasing, then strength of the electromagnet also increases. Secondly, if you are going to increase the current in the wire, if I am going to increase the current in the wire, then again strength of the electromagnet will going to be increased. So the second factor is, if value of current is increased, the strength of electric field, the strength of electromagnet again increases. So if the current is increased, the electromagnetism is going to be increased again. The third factor we have is about the air gaps. This is about air gaps between poles. It means if you are increasing the air gaps between the poles, there are the two poles of the magnet we have. If there is a much air gap between them, the electromagnetism will going to be decreased. So in this case, we will not get the magnetism as required. So you have to keep the gap reduced between the air poles, so we can get the strong electromagnetism as we desired. So if air gaps between the poles increases, strength of electromagnet also increases. So this is how the factors on which the electromagnetic basically depends upon. So there are several factors we have on which it depends upon. So again, this is a very important topic, that how these factors will affect the strength of the electromagnet in magnetism. Now, this is about the factors dependence of electromagnetism. Now, let's move to the difference between the permanent magnets and temporary magnets, because we are using electromagnets nowadays. So you must have an idea about that why we are using them. So there must be some difference between the bar magnets we are using earlier as compared to the electromagnets we are using nowadays. So let's see a difference between the bar magnet and electromagnet. So now our next topic will be difference between bar magnet and electromagnet. Now, earlier we are using the bar magnets as we have, but nowadays we are using the electromagnets. So actually bar magnets are our permanent magnets and these electromagnets are our temporary magnets. Why they are called the temporary magnets? Because as long as the current is passed through these electromagnets, they will going to show you the effect of magnetism. But whenever you stop the flow of the current, there will be no magnetism. It means magnetism will be lost from the circuit we are using. So we can say that bar magnets are our permanent magnets, but electromagnets are our temporary magnets. So this is what about the naming of these magnets we have. So let us differentiate these both magnets in few terms. So here we are using the properties. Here we will write about the bar magnet and then after electromagnet. So this is about the properties we are discussing. This will be our properties. Second thing is about the bar magnet and the third thing will be about electromagnet. So the first property will be based upon their common name. First property will be based upon their common name. So commonly bar magnet is known as the permanent magnet. These are known as the permanent magnets. And electromagnets are known as our temporary magnets. So these have our temporary magnets. Now, second thing is about the nature of this magnet. So, second factor I am discussing here is about the nature. Bar magnets are actually our permanent magnets, so they will retain the value of the current as long as possible. But in case of the electromagnet, what will happen if you stop the supply of the current? These magnets will lose their magnetism completely. So what is their nature? These will have in this magnets current will be there, but in this magnets when current is stopped, magnetism will be lost. As long as the current will be stopped, the magnetism will be lost by them. Now, the third factor is about the polarity. Third factor will be about polarity. On the basis of polarity, you cannot change the poles of the bar magnet you have. If you are given a fixed north pole and fixed south pole, you cannot change them again and again. But in the case of electromagnet, you can change the poles of a magnet as well as. So, the third factor will be poles are fixed. In this case, poles are fixed. But in this case, poles can be changed. So, you can change the poles in case of the electromagnet. Now, the next factor will be about the strength of the electromagnet. It means which magnet will going to show you the greater strength. If I am talking about the next factor, that is our strength, the strength will be, in case of the bar magnet, you have a very low strength, or you can say that the strength is fixed. But we have seen in the electromagnets, if you are going to increase the strength of current, you will increase it by increasing the number of turns. You can increase the magnetism by increasing the current flowing in the coil. So, we can say that the strength of the bar magnet is low. Its strength is low, or we can say that its strength is fixed. Its strength is fixed. Instead of using the term low, we can say that its strength is fixed. But in case of the electromagnet, we can increase the strength by increasing the number of turns of the coil and also the current flowing in the coil. So, in this case, strength can be increased by increasing number of turns or current flowing in coil. So, this is how the strength can be increased. Now, the last factor which is going to differentiate between the bar magnet with the electromagnet is the force of attraction. So, our last factor will be force of attraction. So, in case of bar magnet, the force of attraction is very low. The force of attraction is low here. But in case of the electromagnet, the force of attraction is very, very high. So, here in this case, it will be high. So, this is a table which is going to differentiate between the points of bar magnet and the electromagnet we have. And this is again a very important table, because sometimes in the exam, a question may also be asked that what is the difference between the bar magnet and electromagnet. So, this is all about the electromagnet we have discussed in this lecture. This is again a very important question from theoretical point of view. So, this lecture is over here. Now, if you want to get the complete idea or complete solutions regarding the chapter, that is magnetic effect of the electric current, so you will get the complete chapter package at our website only. The entire solution of the NCERT, the solutions that is related to NTSE, and a very good examples from your day-to-day life. So just subscribe our channel, that is AriserTalent, an online learning platform where you get all the courses you want. So thank you so much and have a nice day.